May. Okay. So 2.340. This is the little proof of what I was saying you are doing. Now, so this has 4 significant digits because the trailing zeros are also significant. Is that clear?
Yes.
In number with point, the trailing zeros are
Significant.
Is that clear?
Yes.
Sure?
Yes.
Very good. Fine. So now we are going to talk about how to add and subtract numbers. Right? That might sound like such a childish topic. I'm going to teach you how to add and subtract. Okay. But yeah, with a little twist. Taking care of significant figures. Let's see. So write it. Rule for addition or subtraction. The rule is same, so same logic applies. Rule for addition or subtraction with significant figures. Okay, rule for addition or subtraction with significant figures. Let's write the rule first. Frankly, the rule is tough. Frankly, the rule is tough to understand when you see the words, but it's very easy once you see one or two examples. Right? So here it is. The answer means result, as many places after point as there are in the measurement with least number of decimal places or places after the point. Okay. Again, you are not supposed to memorize this, but at least you should understand what it's saying. We have to learn how to use it. Okay, answer has as many places after the point as there are in the number with the least number of places after the point. Okay, what is this? Let's think of two masses that we are going to add. Suppose mass of first object, let's say, is 45.27 kg, and mass of another object which has been measured, let's say, is 5.1 kg. Okay? Now do you remember those words, precision and all that?
Yes.
Right? So which has more precision, 1 or 2? 1
1.
has more precision. Is that okay?
Yes.
Because it's measuring up to 1/100 of the kg. Clear? Yeah. Anyways, so precision is not the main point here. I'm just making you recollect. Now if you want to add, suppose when we mix these two objects or two things and we have a total mass. So total mass, suppose if I write it as m, then that would be according to this one. First of all, let's add normally. Okay. If you were to add this, what would be the addition? 150.37. Okay, this is what anybody would do, right? Clear? But it is wrong. Why? I'll tell you. Do we know what's after this 1? You understand what I'm saying? This instrument only measured up to 1. We don't know what's after 1. So this is an unknown digit and you are adding unknown digit with 7. Do you think you will get 7 if you add 7 with unknown digit? This might be 1, this might be 2, this might be 3 also. Yes or no?
Yes.
So do you understand that we cannot be sure that this is actually 7? Clear? Clear or not?
Yes.
The reason being, we don't know what's going to be the digit after 1 because it was not measured that way. So that's why we do not write. So you can round it up. See, if it is 37, okay, we don't want to write the 4th digit, we just want to write till here. So if I round it off, then 37 is close to 40 or 30? 40. Did you understand? So magically the addition of 45.27 and 5.1 according to rules is 50.4, not 50.37. Did you understand? Let me just write 50.37 over here for your reference. Then it was actually 50.37, but then we use this rule. What's the rule? The answer should have as many places after the point as there are in the measurement with the least number of places after the point. Okay, look at this number. How many places are there after the point here? 2. Sure? Yes. Everyone get there? Yes. So here are 2 places after the point. Okay, in this one, 1 place after the point. So which is less? 1 or 2? 1. So answer should also have that much, the least number of places. So finally answer should have how many places after the point? Only one place, not 2 places. Understood? Yes. Only 1 place, not 2 places. Clear or not clear? Yes. So which is the right answer? 50.37 or 50.4? 50.4. Got that? Yes. Rule is clear? Yes. Fine. Let's try one more. Suppose you were to add some lengths. Let's say length of something is 50 centimeter, length of something else is 0.723 centimeter, sorry, and L3 is, let's say, 10.5 centimeter. Suppose we want to add these 3. We want to find total length. By adding these 3, we want to find out. What do you want to find out? Total length. Clear or not clear? Okay. First of all, we just have to add them normally. Okay, then we'll talk about the places. If we add them, a little problem will arise. This is in which unit? Can you add meter with centimeter directly? No. First you have to convert from meter to centimeter. So these many meter will be how many centimeter? 1 meter is how many centimeter? 100. So multiply by 100, isn't it? Yes or no? So how much in centimeter? 72.3. Is that clear? Yes. Okay. Okay, so by addition you get L1 plus L2 plus L3 is equal to how much? 32.8. Okay, but should we write this as the answer? No, 133. What should we write as the answer? 132 or 133? 133. Okay, let's see. First of all, how many places after the point here? 0. There is no point. How many places after the point here? Okay. How many places after the point here? Clear or not? Yes. So answer should have how many places after the point? 1 or 0? 0. Why 0? Least number. Which is the least number of places? 0, 1 or 1? 0. Clear or not? Yes. So that means we should not be writing anything after the point. Okay? So I have to round this off. Now this 2, 8. There are 2 possibilities. Either you can make it 30 or you can make it 20. Clear or not? You know how to round off, correct or not? This is 2, 8. You can either make it 30, that is increase this 2. Okay, 28 is close to 30 and 28 on the other side is 20. So which one should you go by? 28, 30. Yes or no? Clear? Yes. So final answer will be 133 centimeters. Did you understand the method? Yes. Everyone got there? Yes. Fine. Open your textbook now. There is a question which we are going to solve. Okay. Regarding this problem. question that we are going to do is number 12 from the book. Okay, from the exercise of the book, number 12. Okay. Mass of a box measured by grocer's balance is 2.30 kg. In everybody's book, is that mass 2.30 kg or is it something else in anyone's book? 2.30. 2.30? Only one zero given, right? Or two zeros? Sure?
Yes.
Okay. So 2.30 kg. Please don't say sorry, it doesn't make a difference if it's 10 or 20. It makes a big difference. Do you remember what difference it makes? Okay. So M1, the first mass given, how much? 2.30 kg. Okay, now second, okay, what given there? Two gold pieces of mass is 20.15 gram. So M2, how much is M2? 20.15 gram. And M3, 20.17 gram. They are now added to the box. So all that is put in the box. Okay. What is A? The total mass of the box. So in the part A of the question, we have to find out what is the total mass of the box. So we have to use this rule of this. Right? We have a similar problem as it was in this example I gave you. So M1 is 2.30 kg. M2 is 20.15 gram. Yes? And M3 is 20.17. Okay, are the units same? One is kg, the other are. So we have a choice. We can either convert everything to gram or we can convert everything to kg. Okay? You want to convert to gram?
Yes.
No problem. Fine. Not wrong. But my general advice or recommendation to everyone is that throughout this book and throughout this course, we are going to be using SI. So as far as possible, if you can do it, you should convert units to SI. That is, instead of converting kg to gram, we should convert gram to kg. Is that okay? I am not saying by converting kg to gram you will get wrong answer. I am making it very clear. It would still be correct. Okay, but a good habit is that as far as possible you use SI units. Okay, so I am going to convert these two masses in gram into kg. Right, they are in gram right now, we will convert them to kg. So if from gram I have to convert to kg, I have to divide by 1000. Is that okay or not okay? Everyone? Sure? So this is going to be, if I divide by 1000, what will be the first one? I mean M2? 0.0022015. Is that okay or not okay?
Yes.
Sure?
Yes.
Everyone got that?
Yes.
Dividing by 1000. And similarly 0.02017. Right? So these are the three masses now. We want to find in the part A total mass of the box now. Okay, this is the box and two pieces of gold are added. So what's the total mass? Let's say M equal to M1 plus M2 plus M3. Total mass. We have to add and we have to take care of significant figures. First of all, let's add without significant figures. I mean, without worrying about everything. Just add. What do we get? You tell me what to say. Hurry up, smart. 2.34032. Yes or no?
Yes.
Okay.
Yes.
અને એક વસ્તુ કહું તમને ન ગમે એવી તમે લોકો તમારી બુક નું બહુ ધ્યાન રાખજો રફર યાદ કરી નાખવાનો હોય બાજુમાં ઇઝ ધેટ ક્લિયર પેજ ફેરવીને પાછળ જાઓ ને પાછા આવો ટેક્સ ટાઈમ યુ ગેટ વોટ આઈ એમ સેઇંગ do the rough work right there at the site. I'm sure you will realize that nearly half of your book is empty already. Okay, you don't fetch any marks for neatness of your notebook now. Okay, but you primary school mandatu. You understand what I'm saying? Okay, થોડી book ગંદી થાય તો એમાં કઈ વાંધો નહીં, it's fine. કોકવાર આવું કરવું પડશે. That's a good sign actually, right? I can completely assure you કે જેની બુકમાં કોઈ દિવસ આવી ક્રોસ ન માર્યો હોય ને એને કંઈ સરખું ભણતી ભણ્યા જ નથી. Right? Not in 11th or 12th at least. Because sometimes, someday you will do something wrong. Okay? Otherwise, I have also seen some students, right? In some other notebook. And then they go home and copy it in another one. Making a fair notebook. But એટલો બધો time છે તમારી પાસે લાવો homework. You understand what I am saying? Please don't do all these things. That will be a waste of your time. એના કરતા sum solve કરો વધારે આવશે. Got it? Okay, making a nice looking, pretty looking notebook is not at all required. Your notebook should have things, that's it. That's the main thing. Nevertheless, it should be readable basically. Right? But how no lagta. Okay, never mind. So here, 2.34032 kg. How many places here after the point? 2. Sure?
Yes.
Okay, here? 5. Here?
5.
Okay, which is least? 2. So tell me the final answer now. Raise your hand. What should be the final answer of this question? Remember, we want 2 places after the point. 2 places after the point. Okay. Alright. Yes, you, what's your last name? I forgot your name. Surya Dev, right? Yeah, okay. What's your answer? 2.34. Sure. Absolutely. Who agrees with him? He is saying 2.34. Who disagrees? Nobody disagrees? You disagree here? What's stand up and say louder? 2.35. Why did you choose 5? But this is already 40, isn't it? 40 is closer to 40 or to 50? What you? Yes or no? Clear or not clear? Okay. So final answer is 2.34 kg. Got it?
Yes.
Sit down. Well done. Clear everybody? Okay. What about B part? Read it. Yeah, one. Read it first, do it, then we'll go back, check the answers later. Okay? Don't see the answers right now. Anyone? Find B. The answer to B. Find the difference in the masses of the 2 pieces. We have to find difference now. Again, same rule works for subtraction. There is not a separate rule. Same thing works. Okay, so let's subtract. Let us subtract. What do we have? M3 minus M2. Understood? Subtract. And take care of the rule. Okay? Take care of the rule. So many zeros?
Yes.
Okay. Did you follow the rules, everyone?
Yes.
It should have as many places as in the number with least number of places after the point. So this one has how many places after the point?
5.
This one?
5.
So answer should have
5.
5. Is that clear or not?
Yes.
Sure?
Yes.
Okay, so what's the answer? 0.
0.0002
kg. Clear?
Yes.
Sure?
Yes.
Okay. So that's your answer. If you want to write this in gram, suppose, then you can convert it now. So you have to multiply by 1000 because 1 kg is 1000 gram. Okay, so how much would that be? 0.02 gram. Clear? It would have been same even if you would have subtracted directly. Do you see that? Yes or no? Suppose you subtract them, then 7 minus 5 is 2, so you get this 2. Got it? Okay, take the answer now. Take the answer at the back. I think it is given wrong. Given right? Are you sure? 2.3 kg go together. 2.34 kg. 2.3 kg is wrong, isn't it? The whole thing is about significant figures. So if you say 2.3 kg and say no, that's nonsense. It is 2.34. Rules equal to rules follow karo je? Yes or no?
Yes.
Okay, what about B? 0. Sure. 0.02 gram or kg. Fine. So change the answer to this in the book. There's a mistake. Again, this is one of those things that is different in high school and higher secondary school. We give no value to the book's answer at all. Okay, we don't care what's the book's answer. As long as the concepts are okay, the answer is right. Okay, just because book says 2.3, that doesn't mean correct answer is 2.3. Right?
So they might not have been counted the 0 after the 3.
Yeah, that's their problem, right? Okay, yes or no?
Yes.
But
So according to rule we are counting.
exactly, we have to. This 0 is always significant, right?
Yeah.
Okay, so okay, well then. Now, time for the next part of this kind of rules. Second, instead of addition subtraction, this time multiplication and division. So, answer has as many places after the point as there are no. Has as many significant figures or digits as there are in the measurement with the least number of significant figures. In fact, this is actually easier to use than the addition sum. So this is the rule for multiplication division. Okay? But yeah, the results are even more weird sometimes. If you show it to a kid, that kid will say, you don't know how to multiply. Right? Did you write down the rule? Then, yes, it is the multiplier. Right. So instead of decimal places, here it's all about significant figures. Let's take an example. Suppose there is a rectangle. Someone measured the length of the rectangle as, let's say, 75 centimeters. And suppose they measured the width of the rectangle as 3 centimeters. So basically it's like a long strip. Is that okay or not okay?
Yes.
We want to find its area. Who remembers formula for area of rectangle? Raise your hand. Formula for area of rectangle. આ તો આવડી જો મજા આપનો કરો મારી સાથે. Formula of area of rectangle. Okay. Area is equal to L into B. આનો તો આવડતું? Those who didn't raise hand, I have to ask you that. આવડે જ નહીં કે ન આવડે? A equal to L into B. Yes or no?
Yes.
Don't be shy. Raise your hand. Okay. If you know it, raise your hand. Try to answer. If you don't know it, raise your hand and ask doubt. Well then, A is equal to L into B. Let's multiply them. આવડે કે નહીં? 75 with 3 કરો. What do we get? 225. Yes or no?
Yes.
Sure.
Yes.
Centimeter square, right? But this is wrong according to the significant figure rule. I'll tell you why. You see, the problem is again the same thing. We don't know what's here. We don't know what's after this place, after these three lines. Okay, and that is why what happens is wherever these places go, they will carry the error with them, right? Wherever these places go, they will carry the error with them. So, when you do this multiplication, we have to only look at the number of significant digits. Like how many significant digits here? Two. Very good. Two significant digits or figures. How many significant digits here? One. So which is least? One. Sure?
Yes.
Okay. So we have to round this one. Okay. 225 is not the correct answer. K was equal to the 75 to 3 is not 225. Okay. Because we are doing it properly. Because this is a measurement, we don't know what's after 3. And that is why the correct answer will have only one significant digit. So, what would it be? Have a look. How many significant digits here? 3. We have to make it 1. Okay, we have to round them. Okay, so 225. First of all, I will do it in 2 steps. I write it like this first of all. Is that okay or not okay?
Yes.
Sure?
Yes.
And you will notice. That makes it easy. Right? Now, we want only one digit, but this has 2. So, either we remove them, then this will become 2.00, or we can increase this 2 to 3, then it would become 3.00. Yes or no?
Yes.
I repeat, these two are to be removed. This will remain because we want only one significant digit. So, which 2.25, is it closer to 2 or to 3? 2.25, closer to 2 or 3? Both? अरे यार કેમ આવું કરો છો અમુક લોકો હજી 300 વિચારતા હતા. What's the difference? 25. What's the difference? 75. When is it closer? 200 or 300? 200. So 2 into 10 raised to 2. This is your answer. Understood? 2 into 10 raised to 2. So 75 into 3. If you take a rectangle, 75 centimeter, 3 centimeter, then the area of rectangle is not 225. Area of rectangle is 2 into 10 raised to 2. Is that clear?
Yes.
Sure?
Yes.
Not 225 again. Got it?
Yes.
Try one. Same thing, of course, you can do for division also. Okay. Suppose you know that mass of some object is, let's say, 50 kg. 50 kg. Okay, or let me just write it as 5.0 into 10 raised to 1 kg. Okay, using scientific notation. Right? And the volume of that object, V for volume, the volume of that object is, let's say, 25, or rather, let me change a little bit of this. Let's say 12.5 meter cube. Okay, 12.5 meter cube. Okay, right? Now I want to find the density of this object. How do you find density? Density means mass upon volume. Okay, do that. Come on, divide, but follow the rules properly. Okay. First of all, divide normally like you have been doing so far in your life. Okay? And then look at the significant digits, right? So how many significant digits here? 1, 2, 2. 5 is significant, yes or no?
Yes.
Okay, then This is a number with point, yes or no?
Yes.
In a number with point, the zeros at the back. Significant or not significant? Significant. Everyone.
Yes.
Like I said, you have to know the rules at least, okay? So 0 is significant. Clear?
Yes.
2 digits are significant. Here, how many significant? 3. Very good. So here 3 are significant. Which is less? So final answer should have 2 significant digits. So try to write the answer in 2 significant digits. Raise your hand if you have done it. Anyone else finished it? Okay. 2.5. And is there a unit? What will be the unit? Kg per meter cube. Okay. And you are sure this is the right answer? Okay, sit down. I think it's not the right answer. The division is wrong. Raise your hand if you have done it. Come on. Others, hurry up. Divide. Can you agree division of this? Mantra, did you divide or not? What do you get after dividing?
0.3.
Division no able. Do it again. 0.3 no આવે. 0.4. Did you take care of this also, everyone? Raghav? 4.0 is your final answer?
Yes, sir.
4.0. Your answer, Disha?
Sir, I want 4.
You got only 4. Final answer is 4? Or the division is 4?
Division is
Then did you take care of this? Sit down, think about it. Okay, give a final answer. You have an answer, Sama? 4? 4.0. Yes? 4.0 or 4? Harsh? 4.0. In support of friend, is it? You got it right? Okay, very good. Yeah?
4.0.
Your answer?
4.0.
Or 4? 4 or 4.0?
4.0.
Sir, 0.4 into 10.
0.4 into 10. Try to write it in scientific notation. Why did you choose 0.4 into 10?
I thought because 4 and I got 4 answers, so 0 point into 10, then answer will become 4 and scientific notation.
No. 0.4 is not scientific notation. What's the rule for scientific notation? First digit should be 1, 0, isn't it? Okay or not okay? Well, sit down. Well, try to. Anyone else?
4.0.
ઊભા થઈને બોલવાનું 4.0. Sit down. Let's first of all we are going to divide it normally. So this is basically 50 by 12.5. Yes or no?
Yes.
Forget about significant figures, everything right now. Just divide. Let's focus on dividing. Clear?
Yes.
Okay, 50 by 12.5 means 500 by 125. Yes or no?
Yes, sir.
Sure?
Yes.
Okay, so when you divide, this will give an exact 4. Clear or not clear?
Yes.
125 into 4 is 500. Okay? This gives an exact 4. But if I write the answer just as 4, then we have a problem. The problem is that this rule says that the answer should have as many significant digits as the least number of significant. How many is the least? 2 or 3? 2. This one has how many significant digits? But that's not proper. We should have 2 significant digits. We should allow nothing. If you keep dividing this, do you realize you get 4.00000 as many times? Yes or no?
Yes.
Sure? So how many zeros should I write? 1 more 0. Is that clear or not?
Yes.
4.0, nothing, yeah. Kg per meter cube. Did you understand this answer?
Yes.
Okay. Suppose our equation option kya hai? Over there 4, 4.0, 4.00 like that. You understand what I'm saying? So you have to do it carefully. Alright? Don't forget the rule. The rule is that it should have 2 significant digits. Is it clear? Yes or no?
Yes.
Okay. Now, a little bit of comment or a point on rounding things off.
So, are we counting this 10 raised to 2 as significant?
Good question.
Sir, because there is no rule for that.
Really?
Yes, sir.
I didn't make it right there.
Only 4 rules you made us right.
Okay. Sit down. Then, I'm so sorry then, probably I should have mentioned it, but due to some reason I forgot. This 10 raised to 1, which is the power of 10 and all that, it is never to be considered in scientific notation. If you want, you can write that down at the moment. Okay, if you have space where you have written rules of scientific notation, way back. Not scientific notation, sorry, significant digits. If you have space where you have written about significant digits for the first time, I suggest that you write it with that. Okay? The rule for that 10 raised to and all that is that 10 or its powers, okay, used in scientific notation are not considered significant. Did you understand this sentence? Look at this. This is scientific notation. Correct? So the rule says that 10, this 10, or its power, all of that, is not considered significant. So here only 2 digits are significant, which 2, 5 and 0. Got that? Okay or not okay? The reason is that this is just used to multiply or divide. Basically. Right? 10 raised to 1, 10 raised to 2, 3, 4, all that is just about writing zeros in another form. Okay, that's why we never consider it significant. Clear or not clear? Right? So once again, just to clarify, if someone says that we have number 2.3 into 10 raised to 5, then how many digits are significant? Only. Got it? 10 and 5 and all that is of no use when we are considering significant. Got it? Okay, because it's not a part of measurement again. Right? Measurement would be only this and power would be put just like that. For example, someone says you measured it, okay, and you got 2.3 kg. Now you want to write it in gram. Suppose someone said that measurement is 2.3 kg and now you want to write it in gram, then wouldn't you write like this? Yes or no? So out of all this, what was really measured? 2 and 3 was measured. This one was not measured. You just multiplied it because you wanted to convert from kg to gram. Understood what I say? Okay? So, well, now, yeah. So I was telling you about rounding off rules, and that also reminds me that I will give you some homework just a minute. From the textbook, following questions are homework. 10. Question 10 from the exercise. Okay. 1 and 2 from the exercise. They are about converting units. Okay. Question 1, question 2 from the exercise, question 10 from the exercise. Okay, 12 we have already done. Fine. Okay, clear what's the homework?
Yes.
10th one is so easy. You just have to decide what is significant and what is not. Okay. Everyone will do the homework honestly. Let me be clear. If you see the solution from somewhere or the answer from somewhere, it's of no use. એના કરતા નહીં કરતા એ રમી લેજો થોડી. Okay. Now, rounding off. Okay, rounding off the digits. This is not that tough really. નાના છોકરાઓને આવડી જાય એટલે તમને આવડી જશે ફટાફટ. If someone says there is 4.0, 4.1, 4.2, 4.3, 4.4, then these all have two significant digits. Yes or no?
Yes.
Sure.
Yes.
And if we are required to get only up to one significant digit, then obviously the 4 will be the choice. Is that okay or not okay?
Yes.
Someone find it? We should 4.1. Is it close to 4 or 5?
4.
So we should pick 4. Correct or not?
Yes.
Sure.
Yes.
So this would be 4 in one significant digit. Understood? Like this. Suppose you have got something like 27.6, 27.7, 27.8, 27.9. All this, when you round it off to one less digit, okay, this has 3 significant digits, and suppose you want to round it off to 2 significant digits. So, do you realize you should make it 28? I see you are getting a feel of it now.
Yes.
And this is 27.6, 7, 8, 9, so it is close to 28, so let's make it 28. Did you understand?
Yes.
But yes, don't write 0.0, that would be wrong. You get why? What's wrong with 28.0? It has 3 significant digits, right? So what you need is useless then if you write 28.0. Got that? But in all this, you see what digit is missing? 0, 1, 2, 3, 4. 5. Because the rule for 5 is a little weird. Oh, so what's the rule for 5? It's as follows. If digit before 5 is even, okay, then simply drop means remove 5. That is when you are rounding it off, if the digit before 5 is even, then simply remove 5. For example, 54, or rather let me write 74.5. If someone says round it off to 2 digits, it shall become 74, not 75. Is that clear?
Yes.
Is that clear or not?
Yes.
Why do we have such a weird thing? Because 5 is exactly in the middle. Okay, so we have 2 rules. This is the first one. Is it understood?
Yes.
That is, 5 is this digit. We want to round that off. What's the previous digit or the digit before it? 4. 4 even or odd?
Even.
That's why we follow this rule. Did you understand?
Yes.
Sure?
Yes.
Okay. Next. If digit before 5 is odd, then increase that digit by 1 when 5 is removed. Again, nobody is going to ask you these sentences, right? They want to write the rules for 5. Nobody cares whether you can remember these words. But you should be able to understand what this is telling you. So suppose it is, let's say, 29.5. Suppose it is 29.5. So here's 5. What's the digit before 5?
9.
Odd or even?
Odd.
So what happens here?
30.
It will become 30, not 29. Did you understand?
Yes.
Yes or no?
Yes.
Sure? Got it completely? Okay. One more to try. Suppose someone gives you 723.5 and you want to round it off. It should become 723. 723 or 724? 724. Clear?
Yes.
Sure?
Yes.
Because 3 is
Odd.
understood the rule?
Yes.
So you see, like I said, 5 is in the middle. So half the times we go for decrease or no change, and half the times we go for increase. Make sense? Or not clear? In these we go for no change. In these we go for increase. For example, this was 27, but it becomes 28, and 5 is the middle. So half the time this way, half the time that way. Got it? Okay, so that's the rule for rounding off 5. Don't be confused with that. This is something, no, you should forget it. Because possibly earlier you were told that always if it's 0.5 then you have to increase by 1. I don't know whether you might have been told this, but that's not how it works in physics. Okay, so be careful. Right. So with that, let's end this class.